So let's talk about how to find the area of a triangle. The area of a triangle. Now, we've been finding areas of triangles for many years now using our good old area equals half base times height. Now, this is where the base and the height are at right angles to each other. So with a right angled triangle, they're at right angles to each other, the base and the height. Or if you were given a triangle where you had one of the lengths and then the height of the triangle at right angles to each other. So you can only use this formula when you have the two measurements that are at right angles to each other. Now, if we don't know that, we can use Pythagoras Theorem, or other people have, to find this formula. So where the area is equal to half BC sine A. So what does that mean? So as we know from our work about the notation of what we name the triangle sides, that we have a triangle like that. So if I've got side A, that is angle A, side B, side C. So like that, okay? So that is angle A, all right? So what this is saying, so half times B, C, sine A. Okay, it's sort of showing you a bit down here how it's all come about. All right, but that will basically give you that C sine A will give you the height. Okay, it's derived from Pythagoras formula. Okay, where now it's important that this B and C are two sides that are adjacent to each other, and A is the angle between them, all right? So B and C are two sides adjacent next to each other, and A is the angle between them. So here, find the area of the area of the triangle, correct to two decimal places, and you can see we've been given two lengths and the angle between them, so I can use this formula, half BC sine A. I just substituting my knowns and I then get my area. So the area of A, the area of the triangle is 16.25 meters squared. Okay, so this is from the 2005 exam 1, so multiple choice. This is a question 1, so of course considered in the easy category. So the area of the triangle PQR is closest to. So I've got a side length there, PQ, side length there, PR, and the angle between them. Okay, so area equals half BC sine A. Area. So area equals half times 10 times 5 times by sine 25 degrees. And I'll just get my calculator. So half times 10 times 5 times sine 25 degrees, approximately equal to, so the area is equal to 10.57 10.57. So that is closest to C. Now, looking at that, 81% of the state answered correctly. 7% answered E. I wonder if they left out the half there. They may have done that. Okay. Now, sometimes we don't know any of the internal angles, but we do know the lengths of all three sides. And this is when we use Heron's formula. You might remember this from year 10, maybe year 9. So we know all three sides. Now to do this, we've got to do two calculations. We've got to find something called the semi-perimeter. I don't know where the name came from either, but it's all three sides added together divided by 2. And then the area is equal to the square root of S times by S take away A times by S take away B times by S take away C. That's the length of A, B, and C. Now, it looks a bit complicated, but it's pretty straightforward to use in practice. So here we have area of triangle PQR, correct to 1 decimal place, or find the area of the triangle, correct to 1 decimal place, given that P, Q, and R are those measurements in centimetres. Okay, so our first step, seeing as we know all three sides, we don't know any of the internal angles. That means we have to use Heron's. So our first step is to use our semi-perimeter formula to find that out. So it's 9.5. All right, then I'm substituting all my knowns into my area formula. So area equals square root of 9.5 times by 9.5 take away 6 times by 9.5 take away 9 times by 9.5 take away 4. So you can see it's all those sides there. So area is equal to square root of 91.4375. So our area is approximately 9.6 square centimetres. So going back to 2006, exam 1, now this is question 5. So that's sort of middle of the range type of difficulty. A block of land is triangular in shape. The three sides measure 36, 58 and 42 metres. To calculate the area, Heron's formula is used. The correct application of Heron's formula for this triangle is, okay, so we've got a triangle, 36, 58, 42 metres. All right, now this is a question where they're not actually asking you to work anything out, but they're asking you to show that you know what calculation you would use. All right, so our first step is to figure out our S, because that will eliminate a lot of possibilities, won't it? So S is all our sides added up, 36 plus 58 plus 42 divided by 2, control enter, 68. So our S value is, is 68. Okay, so we know it can't be A or B. Now, you can probably look at that and go, okay, the mistake in A and B, they probably haven't divided by half there, have they? That's probably the mistake they've made there. Okay, so now we think about the rest of the formula. Oh, also can't be E, can it? Because although they've got S correct there, it's not correct in the others. Okay, so Now we look at the formula and go, well, okay, x, we've got to go s minus each of the side lengths. So s minus 36, yep, s minus 58, yep, s minus 42, yes, that is the correct answer. Now just looking at D to illustrate why it's not the correct answer, these aren't side lengths, are they? They're half of the side lengths. So 18 is half of 36, 29 is half of 58, 21's half of 42. That's incorrect, isn't it? C is the only correct answer there. So yes, 80% of the state answered correctly there. 13% of the state answered A. So, yep, all those side lengths are correct there. So I think that might explain that people were looking for the side lengths, and the side lengths were also correct there. But I think, yeah, with that semi-perimeter, they didn't divide by 2 there.